Hello everybody, my name is Alessandra and today I will talk about remotely piloted aircraft as support for the study of urban parameters. This article was produced by me and the co-author Anderson Ferreira. This is a research partnership between architecture faculty and geography. In this article, we present a survey conducted via remotely piloted aircraft to define urban morphology conditions for implementing monitoring weather stations. The objective is to obtain as products the digital surface model, the average height of the elements that make up the beauty space, vegetation plus beauty elements, and the 3D model of the area under study. These stations will support the participatory model, Appline, for remote acquisition of data from users regarding comfort conditions in open space. For this, the methodological process was carried out in two items. First, the identification of the study area, outlined in yellow, a segment of USP campus. The use of Appline will make it possible to verify the perception of open spaces in relation to the thermal environmental conditions, acoustics, lights, and ergonomics, and allow the quick acquisition of these opinions coming from users. And the second item is remotely piloted aircraft survey. The following 5 steps were necessary. 1. Mission planning. Definition of the length, width, and distance of flight are important factors to be considered. They are relative to the time and calculation of the resolution of the area to be flown over. 2. Mission flight. In general, the flight occurred at the maximum height of 120 meters and covered an area of approximately 63 hectares. 3. Calibration of the quality images. The image calibration process was performed with the Agisoft MetaShape Professional by inserting the interior and exterior orientation parameters of the sensors. For this purpose, the software requires the following information: image resolution, focal distance, and center coordinate of the image. Step 4. Survey of the ground control points was made through the Global Navigation Satellite System, positioning of the reference stations and the ground control points defined for the mapping of the study area. And step 5, generation of the digital surface model, DSM, was created from a cloud of points with 3-dimensional coordinates representatives of the objects of the study surface, vegetation, buildings, etc., resulting from the process of image alignment. The items listed were the results obtained with the acquisition of the images by RPA. The image generated by the RPA with the geographic distribution of the buildings, vegetations, and the main avenues of the study area. The final resolution of the generated images orthophoto mosaic is approximately 5 centimeters. The final resolution of the generated image DSM is 30 centimeters. In image A, it can be seen that the altitudes vary between 720 to 780 meters, with the height of the buildings varying between 10 and 25 meters. The topography profiles of the DSM line AA and BB respectively shows that both stations are in relatively low areas with treetops varying between 5 to 20 meters. In image B, the avenues where they are installed are 40 meters station 1 and 20 meters station 5. With the acquisition of the images via RPA, it was possible to identify the average height of the elements that make up the beauty space, vegetation plus beauty elements, as well as create a 3D model of the area, image A. Image B. The digital terrain model was generated to support the 3D visualization of the elements. It also showed the area's topography, an important element in geoprocessing applications, for example. The height of the elements, beauty and natural, that make up the study area, image C. The subtraction of the digital surface model from the digital terrain model image was important in generating the high model of the surface objects. Information about the geometric parameters of the city, such as flat area index, frontal area index, and average height of buildings, are the basis of several urban studies, such as roughness and ventilation, for example. As in most Brazilian cities, there are no 3-dimensional models. The use of this acquisition methodology becomes an important tool for collecting information to be used for visualization and mapping of areas in city. Installed in 9 August 2018, the stations had a trial period for acquisition, storage, and verification of data collected and viewed on the server. The continuous measurement sensors are installed at 5 meters high. The sensors collect data on the following climate variables: air temperature and relative humidity, direction, and wind speed. Data is recorded every 15 minutes, and this information is transmitted to the server and stored for subsequent correlation with user responses and evaluation of the sensation of environmental thermal comfort. Each station has its own battery and solar panel to recharge the battery if necessary. After March 15, beginning of the social isolation, COVID-19, the data is stored in the USB server. In MBJ, it's possible to identify that for both stations, the data of relative humidity and the average air temperature have similar profiles. In image B, it's possible to identify the wind low velocities, averages, and gusts recorded by the two stations, as well as the predominant direction of each speed. In general, it's possible to identify that there is a predominant direction of the south-southwest quadrant for both stations. The server by RPA provides to be more interesting than the high-cost alternatives, more efficient and applicable in any urban context. The use of this type of survey is a versatile means of data acquisition. There are several morphological parameters that can be obtained by RPA. These are flexible in operation and time resolution, providing more possibilities of using various areas of nodes, such as climate, construction, acoustical, vegetation, etc. This material is based on a project supported by Grant São Paulo Research Foundation, FAPESP, and other institutions. Thank you, be well, and see you at the next clip.